Hello, good day to all. Today, our group will be presenting our mini project titled Food Libebeli. I'm Alicia Nicole Bootwill, and I will talk about my roles in the group and introducing the project. At the same time, I'll talk about the objectives of our project and the key features of our project design. And to start off, my roles in the group is to manage the appearance of the robot and its major functions. I'm also in charge in writing the project of our group. With the theme of fighting against COVID-19, our group has decided to focus on the health sector and design a robot that can deliver food to COVID-19 patients and at the same time sanitize the healthcare area. And please note that this project of ours is being focused in being utilized in the hospital, and we came up with 4 main objectives. Number 1, to sanitize the healthcare area. Number 2, to deliver food to COVID-19 patients. Number 3, to lessen the burden of healthcare workers. And number 4, to eliminate the problem of lacking manpower in the hospital. And now I'll be talking about the features of the robot. The robot itself has a mobile robot coordination system with a PCB and microcontroller embedded in the base. Therefore, it is capable of transporting the food to the patient on its own, thus reducing the contact between the patient and the healthcare workers. Besides, the robot itself has wireless charging features located at the bottom of the robot, making it convenient for the healthcare workers to manage or maintain it. To add on, the robot has a transparent cover on the top, and besides, the robot also has a UV light installed at the bottom of the robot just for disinfection purposes, and it says that UV light is very suited for disinfection purposes. Last but not least, the robot has also built-in ultrasonic sensors around the box so that when the robot moves around, it can prevent to collide with other objects. And one really interesting to note that this product can be used outside of the COVID-19 pandemic, and it can be used in other various fields. Our group really hope that this product will help increase the overall hospital efficiency in fighting against the COVID-19 pandemic. And with that, I will pass the baton to other group mates. Thank you very much.
Good day, sir. My name is Hu Jun Singh, and this is our project, Libebeli Food Delivery Car. So, okay, let us see through the car inside. As you can see, there is a lot of X joint. This X joint is used to increase the level of the conveyor belt so it can reach the patient table with the same height, so easily to deliver the food to the patient that are having problem to take their food. As you can see, here is the ellipse shape is used to control the height of the X joint so that it will not collapse while the X joint is moving upward. And also this cylindrical metal is used to prevent the X joint from collapsing. And as you can see, the base is a bit thick. This is because inside have a space so that we can put our PCB, our motor and wire inside the space, so the inside of the box will look a bit more clean. And inside the box we have a bracket. This bracket is used to enable the slider to move and limit the slider to going the wrong way. Then I will pass to Wenson. Thank you.
Okay, good day, doctor. I'm Ong Wen Shen, and I will explain this conveyor belt, what is its function and how it works. So this conveyor belt is installed above the jack support using slider. This conveyor belt is used to deliver the food to the patient table when the conveyor belt reaches the table level of the patient. So we can see there's two cylinders inside the conveyor belt. It is connected to motor that provide motion power. So the cylinder that connected to the motor will convert rotational motion to translational motion using the belt, rubber belt. And the foot on top of the conveyor belt will move to the patient table. This design is used to prevent the spread of virus when the food need to be delivered to quarantine patient, and this design will make the process entirely self-service by only using this robot. Okay, now I will explain how it works. This cylinder uses rotational joint, and both of these cylinder is constrained rotationally, and the bowl is also constrained to the cylinder using rotational to translational constraint, and the bowl is also constrained to the belt surface itself so that it will remain in the same z-axis position. Okay, that's all for the conveyor belt section. I will pass to Wilson Donglensing.
Good day, everyone and lecturer. Thank you for taking your time to watch this presentation. I am Dong Lun Shen, one of the members of this mini project group. I'm in charge in creating the wheel, rim, and axle part. First of all, let's look at the wheel. The material of the wheel is polyamide, which is better in temperature resistance, better puncture resistance, and stronger impact strength. Besides that, we do not use the traditional rim plus tire wheel. Instead, we produce integrated wheel, which shorten the time for mass producing and also material saving. As you can see, stress on the tire is also formed during the production. So for the assembly of a single side of a wheel, the parts we need are two seal bearings, 4 seal bearings, 1 spacer, 1 screw, and 1 axle. In inventor assembly mode, we constrain 2 bearings into the wheel, as you can see in this part. 2 bearings are constrained into the wheel. Or in industry, it is known as press fit method. Okay, the same thing, we press fit the 2 bearings into the body of the machine. As you can see, the diameter of the bearing, the inner bearing, is same as the axle diameter. Hence, we use rotational method, which is one of the joint method to join the wheel, bearing, and axle together. And finally, we use a screw to constrain the axle in place so that the wheel can run smoothly. Okay, so for the practical situation, 4 wheels were individually controlled by each model, which means that to control the delivery machine to turn left or right, we control the rotational speed of each wheel. As you can see at here, when I rotate one of the wheel at the front, the another wheel is stopped. Okay, so just now I have mentioned that 4 wheels were individually controlled by each model, which means that we need to control each of the rotational speed of the wheel. So by this, a programming code is written for the delivery machine. Okay. So in conclusion, I truly believe that this machine will help reducing manpower and reduce contact between patient and nurse or doctor. The main concern for the development of this machine is to fight COVID-19 because of the sudden outbreak of COVID pandemic again since 2020. The medical resources are draining and almost depleted in our country. By this, the existence of this delivery machine will greatly support the medical system and also more manpower will be added to the front line for fighting COVID-19 in Malaysia or globally. Thank you for taking your precious time for watching our presentation video. Thank you, sir. Have a nice day.